Okay, so what I was saying earlier is, I'm not sure how we'll do it tomorrow, but tomorrow you will be picking your Alcoa Reads book, and I had some students yesterday ask me what book I would be picking, and it kind of depends on how many students pick which book. The person that first picked, the teacher that first picked a book is going to have that book. Does that make sense? And then the rest of us, and they didn't pick it's like my book this year. So depending on how many students they have, then another teacher will read that book, or another teacher, you know what I mean? They'll start piling on. So there's the first teacher that this book was selected is going to read that book, and then we just fill in the blanks for more kids sign up. So I'm going to tell you, I'm trying to get I Am Still Alive. So if you want to be in here with me, pick that one. And hopefully there'll be enough for 2 groups, and then I can get it. I'm Still Alive is it's a survival story about a girl that's been in a car accident, and I think she's as lost the use of her leg, or and her mom dies in the car accident. And she's living with she goes to her dad's to live, which is a cabin out in the woods. And these bad guys come and kill him, and she's left in the woods to try to survive and get out. So anyway, that's the one I picked. I figured it was kind of it might be an easy read, but. So there you have it. That's if you want to try to get with me. So, and I would tell you that, not that I'm trying to sell myself, but I would tell you that this I wish that they would give us lists and us try to do it, because I can't guarantee that I'll have that book. But there you have it. So, and I would rather be with a math teacher doing a reading assignment than an English, or even a social, I would call it social studies. Somebody's phone's ringing. Or vibrating.
No, I hear it though. That's not phone. That's like, I don't know. It's weird.
Lawnmower.
Huh?
Wait, everyone be quiet, guys.
It's a lawnmower outside.
Oh, is that what it is?
Be quiet.
I literally told you.
Yeah, I was like, okay. Alright, but anyway, I would rather, because, even if you ever had to do writing with something like they made you guys, no? Yes. You had to write, on that last test this last fall, you had to write, like, for the final couple of questions, it was an essay kind of thing. Well, the people that I was grading, ones, did a lot better probably than an English teacher grading them, so I gave full credit for them as long as they had something pretty much written.
Dang, I should have had you.
So, I don't know, man, it's fine. And I didn't take a grade from the grade book on it either, so. Alright, so let's look at homework. And the first thing I want to look at, well, actually I turned to 16.1, that's where the book was at, so let's start there. problem up here after you guys? Because I just want to look at it with you guys, but I made my honors kind of try to do it. So is there any questions on 16.1? You had 13, 14, and 15 to do. Any question on them? Okay, so working backwards is really important, okay? Where they're giving you, I have a few problems on the test that's like that. Hey, look, here's area, find the circumference, okay? Here's the circumference, find the area, or, you know, so you need to be able to do that, all right? Okay? All right, so if you look at 23, no, that's not right, 32. Okay, I want you to notice that if I took a circle and, okay, we talked about how the polygon inside of it, more sides, you get closer and closer to the circumference, right? Okay, now if you look at this, if I cut this to where I put all these triangles next to each other, it kind of looks like a rectangle with slanted ends, right? And we'll learn what that is later, but for now that's good. And can you see that this, I'm gonna label it here. This is R, right? We're gonna look at this problem on the review packet too that I have. All right, now I know that area equals pi r squared. Okay, so if that's radius, this outside has to be pi r, right? That's the length of it. If I take apart this circle, I know area is pi r squared. So if I know that r goes here, pi r has to be that, okay? Because that's what I'm multiplying together. That's what's left. Does that make sense? So do you see that this length out here is equal to pi r? Can you see the relationship there? Okay, so let me do it again. When you see something like this, all right, Evelyn divides the circle and rearranges the pieces to make a shape. All right, you take a pizza and you cut it, right? And then you take each one of those pieces and you lay them this way and then this way and then this way and then this way, right? You see the pieces of pizza? Okay? And so now, how do you find the area of a rectangle? Length times width, right? So, if this is width, this has to be length, right?
Correct.
Okay, so on the circle, if I match that, that's my width, right? The radius. This is my length. This right here is this. Do you see it? The end of the pizza is here. End of the pizza is here. End of the pizza is here. Okay, do you see that? Okay? So do you see that that is really, really close to the area of a circle? We're finding the area of the circle. That's all I want you to see. I just want you to see the relationship there. Okay? And there's an actual problem we'll do that looks like this. And I'll explain it again then. Okay? With numbers. All right, 16.3. Are there any questions on 16.3? Any questions? Oops, I didn't mean to do that. All right, well, look at number 25. It's on page 860, or 880, I'm sorry, 880. I can't see, I can't walk straight today. Now, they want the area of this little piece here. Okay? The way you find the area of that little piece is you find the area, the sector area. I'm going to shade that in red. Okay? And then you subtract area, triangle area. The triangle area is this piece right here. I'm actually going to erase it in a second, but you see this triangle right there? And you can tell above it they've done it. Area of the sector minus area of the triangle leaves you this piece. Okay? So let me erase the blue. So you see, that will leave us that piece, won't it? Area of the sector area of the whole sector minus area of this triangle will leave me that piece. Does everybody see that? Now, how do you find the area of a triangle? It's 1/2 base times height. And do you see that if I took this triangle and set it right side up, the radiuses are the base and the height? Okay, so area of the sector is 90 over 360 times pi 3 squared minus 1/2 base times height.
At the first I understood, and then after you.
Okay, so sector area is the angle degree over 360, right? Pi r squared. That's what you guys did in all the homework, right?
Yeah.
We got that? Okay, area of a triangle is 1/2 base times height. So,
How do you know?
well, I drew it, that's why I drew up here. I took this triangle, and here's the right angle, right? So So I set it up here so you can see that's the base, that's the height, and that's the base. Or this is the base, and this is the height. It doesn't
These
matter.
are about the same size.
Well, even if they weren't, order in multiplication doesn't make any difference.
Nope.
If my height, if one of them was 5 times 3 is the same as 3 times 5.
Yeah.
So it doesn't matter which one you consider base or height. Okay? So do you guys see where I got my numbers from now? Okay, now, this problem, let me tell you something. This problem is not taking anything that you don't know, is it? Okay, that whole section was area of the sector. You should know how to find area of the sector, right? And Lord help you if you don't know how to find an area of a triangle, because you should have learned that years ago. And most of the time, no, but I'm not, listen, let me finish what I'm saying. Most of us learned area of a triangle a long time ago, right?
Yeah.
So, but what they do is they take that and they put them together, and then you don't know what to do. So what I'm telling you, the reason I'm showing this is that this is not asking you anything you cannot do. You just got to be able to see it. That's the problem, okay? So seeing it is a little hard. The math isn't, or shouldn't be, because you should know both those things. But it's the seeing it that takes learning, okay? So even though it's a simple problem, it's complex because you have to see it, all right? So if you don't see it, if you didn't see it, and you don't think it's easy, it's okay, because it's not, even though it's things you already know. Does that make sense? So, I wasn't trying to say, I thought for a second you guys were thinking I was saying that this was an easy problem, you should already know it, you should know how to do it. That's not what I was saying. It's easy problem, and it's things you know, but sometimes those are the hardest because we can't see it, okay? So, what this problem did, I just want to draw it too on the board. You have, and I'm going to draw it straight up and down. It wants this area, right? That's what it's asking for. So I can find the area of this by angle times pi r squared, right? Okay, right? And then I can subtract this part. Which leaves me this part. Do you see it?
Yeah.
If I have the whole area and I take away this, which is what I did here, I'm just left with this. And this is the same drawing that they have here, right? But do you see it now? Okay, you have the whole piece of pizza, right?
No, that looks like.
And you eat everything but the crust.
No, that looks like ice cream. That looks like ice cream.
I'm not bringing in pizza. Okay, so, but, okay, this is a piece of pizza,
Yeah.
and you eat everything but the crust,
What kind of crust looks like that?
right? And this is how you find the area of the part that you ate. Does that, I mean, that's what you're subtracting from it. This is what's left. Does that make sense?
Yes.
Can you guys see it now? Okay. Okay. 7-1. 17-1, yes. Everybody's a critic.
You have a guess? No, you don't.
It's driving me crazy. That chord was. Okay. Any questions on 17-1? Okay.
I have a question after that.
Okay.
It's not really
What question is yours?
It's just like, okay, so you know how number 5, when you have the centers 9 and 0? Right?
Number 5, when you have centers, what?
9 and 0.
Yes.
Okay, when you're writing that, you just put plus y squared.
Yes.
And then do you do that too, and it's like 1? Or no? Like, why do you just do y squared?
Okay, so this ends up x minus 9
Yeah.
squared plus y minus 0 squared equals the square root of 3 squared. Right? So, what's y minus 0?
Why?
That's y. So y minus 0 is just y, and y squared is y squared, so yeah. And that's why in number,
Is that why y squared is y?
I thought there was one that was x squared plus y squared. Okay?
Okay, thank you.
Back row over here. So you asked me about 12 and 13 or 13 and 14? 12 and 13. Okay. So the first thing I need to do is get this into a circle equation. Okay? So I got to complete the square. So half of 4 is 2. And 2 squared is 4. So I add 4 to both sides. Oops. And this becomes x minus x minus 2 squared plus y squared. And I don't have to do it to y squared. Do you see why I don't have to do it to y squared?
Yeah.
So now I need to know if it intersects the y-axis. So what I do on this one is draw it. And it's at 2, 0, right? The center? So 2, 0 is right here. And it has a radius of 1. So no. A radius of 1 will only take that 2 over to 1, 0. So, okay. And then you said 13? So same thing, except x I don't have to worry about. And what's half of 10?
5.
And
Make sharp.
25 is 9. What?
Wait, what, why didn't you have to, write it out?
Okay, so I'm gonna show you guys something that I actually showed fourth block. I didn't think about showing this way until fourth block, right? And so I'm gonna do one over here.
Okay.
X squared plus 4x plus y squared minus 6y equals 2. I didn't put -2. Okay, so what's half of 4?
2.
All right, so right away I can do this. And what's 2 squared?
4.
So when I write this down, half of 4 is 2. 2 squared is 4. Okay? What's half of 6?
3.
So, and what's 3 squared?
9.
Okay? So, anyway, and they were getting that. So I mean, what do you think? But if it was messing you up yesterday, maybe that way would help you. But I mean, the square, you know, 2 squared is 4, right? 3 squared is 9.
You see how it says y minus
Okay.
6y? That's what transfers it to the teacher supposed to do that way. And if the negative was a positive, that meant that the 3 is a negative.
Wait, can you go back to the,
Oh yeah, I'm going back to the problem. He was just explaining it to him, so I didn't want to move it.
You see y squared minus 6y, the sign up there minus 6y, you just move the minus down. And the plus up there, plus down.
Okay. So x-axis, my center is at 0, 5. 1, 2, 3, 4, 5. And my radius is 3, right? So if I come down 3, 1, 2, 3, that's as close as I'm getting to the x-axis.
wait, why is your radius 3?
So it's no. Okay, because remember that this right here is r squared. Okay? So r is just 3. Okay? Remember that on the test. Don't miss a point because of that. Okay? And is that, let's see, I need to do 18 too. Anybody else have any other questions?
How do you think I did on my Spanish test?
Did I tell you guys to do 18? Yeah, I did.
Wait, we have 18? Did I do it?
Anybody do 18?
Oh, 18.
Yeah. Did you did it?
No, I thought we had to do that. I mean, maybe we didn't, maybe it was one of the omits.
Did I mess up what I took off here?
Oh, I took a picture of when you had,
Yeah, I just switched it around because I made.
you supposed to do that.
Huh?
You supposed to do it.
I did.
Yeah, because we were supposed to skip 17.
All right, so these, I'm gonna plug these two things in. Do you see that? This is x and this is y. So for x, I'm plugging in 2. So 2 minus 3 squared plus n plus 2 squared equals 26. This becomes -1 squared, which is 1. Okay? this is n plus 2 times n plus 2. And I don't know if you remember how to do that from Algebra 1, but you should. It isn't going anywhere. You'll be doing it in Algebra 2. So this becomes, if you do FOIL or the box, n squared plus 4n plus 4. So, oh wait, I don't have to do it that way. I can do it an easier way. Hang on.
That's confusing.
She just plugged in the point stuff into the equation.
Yeah, okay. Honestly, there shouldn't be any reason why you can't get to this point. All right? This isn't any different than those ones you just did. Here's my equation. I put x and y in it. Okay? And this is where I had a student one time say, he wasn't doing what he was supposed to be doing, and I said, come on, you need to work. And he said, I'm not doing it. Math is hard. He said, that's not what he said. He said, math is as hard as crap.
I'm guessing.
Okay. And I said, well, let's think about this for a minute. Is crap always hard?
Sometimes, depends on what you ate there.
And he said, well, no. And I said, neither is math. I said, the great thing about math is what you do, the procedure never changes. So you just did 4 problems where you plugged in the x and y into the equation, didn't you?
Good money, y'all.
Didn't you?
Yes.
Yes, ma'am.
Okay, so why don't you plug the x and y in here? Do you see? If anything, you should have at least been able to write this down. Do you see what I'm saying? Because it doesn't change. The procedure doesn't change. Okay? And he said, and so he did a few, and he said, okay, well, he said, I still can't believe you said that. And I said, well, I can't believe you said math is hard either. So I guess we're even. But you have to remember how you did the simple problems. All right? And it doesn't change. Do you see my point? It didn't change. I still plugged in x. I still plugged in y.
Yeah.
Now at this point, you might not know what to do. But you should at least be able to plug that x and y in. Okay? All right, so now I'm going to subtract 1 from both sides. And I get x plus 2 squared equals 25. Now I get my Algebra 1, I was teaching Algebra 1 and Algebra 2 at the same time, I mean different classes, but at the same time. And they did a lot of revamping standards. They took Algebra 1 standards, they took Algebra 2 standards, and put them in Algebra 1, and then they took standards from Algebra 1 and moved them to Algebra 2, and then they took some standards from Algebra 2 and moved those, and I got really, because I was teaching both, and there were some years I had to teach the same thing to Algebra 2 and Algebra 1, because when it became an Algebra 1 standard, the kids that were in Algebra 2 hadn't seen it yet, because it wasn't a standard when they, you know what I mean? So some of those standards I get. My point is, I don't know if you do this kind of problem in Algebra 1 or Algebra 2. Okay? Yes.
How did you get that 1 again?
Well, my long story is not short. So that's what I was saying. So you kept trying to ask me, but I knew I was answering your question. So I don't know if this might be an Algebra 2 standard, and you might not, the way I'm solving it right now, you may not have seen yet. That's my point, okay? But if I had, let's think about the easy ones. What if I had x squared equals 25? What would you do?
You find the square root of 25.
Yes, I would take the square root of both sides. So I'm doing the same thing. I'm going to take the square root of both sides. And when I take the square root, I get n plus 2 equals plus or minus 5, right?
Plus or minus just means it could have been negative or positive.
Great.
Okay. Negative. Okay, and I know that they shows you that, it's just sometimes you don't use it, sometimes you do, but it's plus or minus 5, right? Negative 5 times negative 5 is what? 25. So the square root of 25 can be either or.
Yeah.
Okay? And I know that you will do what I'm going to do next in Algebra 2. Okay, you ready?
Yeah.
What would I do next in just a normal problem? I'd subtract 2 from both sides, wouldn't I?
Yes.
So if I subtract 2 from both sides, now I get 5 minus 2, and I also have negative 5 minus 2. So n can be 3 or negative 7. Now I'm not going to ask you to do a problem like that on the test. Okay? But again, do you see my point? The procedure didn't change, did it? It's still the same procedure, it just gets a little wacky. Yes. Yes.
If you're subtracting negative 2 from negative 5, wouldn't that be negative 5 plus 2?
If you owe me $5 and you borrow two more, how much do you owe me? Yeah. How'd I get that?
No, the one
Like you borrow
right
mine.
at the very top. 1 plus
2 minus 3 is negative 1
System is corrupt.
squared. Now, if you put negative 1 in your negative 1 squared in a calculator, you don't use parentheses, it's going to give you negative 1 as an answer, but that's not right. And the reason the calculator does that is it sees.
You have to put the negative 1 in parentheses.
Yes.
Okay.
Okay. All right. I will not. Ow.
Why are you laughing?
Oh, that kind of hurt.
Yes.
Yes.
Come on, dude.
What?
10 and 11.
I can't.
10 and 11.
10, 11. Okay, a circle that is centered at the origin and contains the point 0,2. So now my radius is 2. Okay? And radius, do you understand that radius is the distance between 2 points? The center and a point on the circle, right? So if I did the distance between these 2 points, and that stands for distance, not diameter, I'm going to write it out. What's the distance between the x's? 0. What's the distance between the y's? 2. And so I get the square root of 4, which is 2, right? Do you see? Okay? So, and then I'm going to plug in the point 1 and the square root of 3. Okay? And I'm going to check and see if they equal. So I get 1 plus 3 equals 4, which they do. Okay? 11. 0, 0, so x squared plus y squared equals, and can you tell the radius is going to be 3? Because of, it contains that point. So I'm going to put 2 and the square root of 3 in, and I get 4 plus 3, which is no. Okay? Yeah.
Why do you put the square root and the square together? Why don't you just put 3?
What?
Why do you put like the square root over 3 and then
Because I wanted to show her where the numbers were coming from and how you actually put it in. You know, I want to actually put it in. Yeah, I did an extra step. Okay. Any others?
Number 22.
Okay, 22. Intersects the y-axis. Okay, so my center is at -1, 4, right? And I have a radius of 2. So if my center is at -1, 1, 2, 3, 4, it's right here. And if I move over 2, do you see I'm going to intersect the y-axis? Any others?
23.
Huh?
23.
23? Okay, so the center is 0, 0, and the radius is 3, right? So this part is true. This, though, should equal 3 squared, so it should equal 9. So that's false. Any others? No? Okay, so yay, it's time for volume. Alright, so on the test this week, just so you know, it's going to be over 16, module 16, 17, and there's going to be one problem from 18.1 and 18.2 on it. Okay, and then next week, we'll do the module 18 test. We'll also have 1 and 2 on it. Okay, so that 1 and 2, I've only tested one question on it this week. But next week when you do the volume test, you'll have more. All right? Now, volume, if you turn to page 925, now, okay, so the kids have said that there are a lot of tests, a lot of questions on volume, I think, in surface area. Okay, and they don't give you any volume formulas. It's all, you have to remember them. But I think I can show you pretty easily. And where's I have a paper, hang on. How to know them without memorizing them. Okay, so you want to write this down. I'm going to give you all of them right now for all of 18. So volume equals capital B times H. And I want to talk about that for a second. Capital B. Is everybody awake?
Yes, ma'am.
We nudge your, capital B is area of the base. So you gotta pay attention to when we're talking about capital D's and little b's, right? Because a triangle would be area of the base times height, which is a little b, right? Okay, but a capital B means the area of the base. So if I was finding volume of a cylinder, let's say this was solid, area of the base, how would I find the area of the base on this? What? How do I find the area of the base?
Like pi r, like times width.
That's the pi r squared is the area of the circle, right?
Yeah.
Is that base a circle?
It's a rectangle.
Oh, you're thinking.
Pi r, I mean, no, stop. I mean, length times width. 'cause it's
Length times width, right?
correct.
Okay, area of the base times height. So you would find that as volume equals length times width times height.
Are we doing this?
Area of the base, right?
Yeah.
Now, I got a question for you. How did you find the volume of this can?
Yeah, that'll be pi r squared. Because
Area of the base is what?
Pi r squared.
Pi r squared times height. Okay? So in volume, there's we have to talk about pyramids and some things like that, but really other than those, there's not a lot of new formulas. You just have to remember to find the area of the base times height. And doesn't that make sense? Because you want the area of this piece, you want the area of this piece, you want the area of this, right? All the way up. And when you add all those together, you get volume. Does that make sense where the height is coming in? So an area of the base, however many times you can do that up through there. Okay? And there's more. I just kind of wanted to show you that it's not as hard as what we make it out to be, if you can remember that. Okay? So in this first one, it's volumes of prisms and cylinders. And I just taught you the two formulas. Okay, on this page. Area of the base. Now, do you see in the cube? What's the area of the base in a cube?
Length.
Yeah, well, length times width, right? Which is side times side. But I always just remember length times width. Okay?
Yeah.
I thought the area was length times width times height.
no, that's the volume. That's volume.
We just make the area of the base.
Isn't that just what we were, length times width times
yeah,
height?
yeah.
I don't fight. I don't argue.
All right. If you turn to 928. Okay, an oblique prism do you see it slanted? That oblique means it's slanted, okay? And I don't really care if you know that word. A cylinder, right? Oblique cylinder, it's slanted. Well, I almost tried to move this up. All I want you to know is the slanted shapes. You find volume the same way. Area of the base times height. But do you see the height is straight up and down?
So no matter.
Okay, you're not doing this kind of height. You're doing this height. Just the same as you did for one that stands straight up. So if it's leaning like this, you gotta take the height as this way. Looks like a triangle, right? The height is not the slanted part, it's the part that is perpendicular to the bottom, the one that goes straight up and down, doesn't it? On a triangle? Right? So, and it's called Cavallari's principle. And somebody told me that they actually said that on the EOC in one question one time. That they actually used that. Using, and the question would have went something like this. You don't even have to know that that's the right word. Okay, using Cavalari's principle, find the volume of this shape. So all you still have to know is your volume formula. Area of the base times height. Okay? Alright? So just because they say that weird word on it, you know how to do the problem. And in that case, it's good that a lot of you don't even read those things. You just look at the numbers.
Oh, sometimes I give up, I don't understand.
Okay, so let me say something about that. Now, the EOC can have easy problems anywhere throughout the test and hard problems. It's not like all the easy ones are first and they get harder as the test goes, right? They're all mixed up, okay? Now, if you think about the test is scored on a comparison level. So that test is graded on how well everybody else did, okay? So all I'm asking you guys to do is get the easy ones right, okay? So if you think about it, Joe, Susie, Sally, and Jim all get the easy ones right. And you're going along, and you finally get tired and you miss an easy one. And then, they get some easy ones right, you get some easy ones right, you look out, get a hard one right, they look out, get a hard one right, but then you miss another easy one. Because now you just don't even feel like taking it anymore.
Oh, yeah.
Do you see what I'm saying? So all I ask you to do is take your time when you go through the whole test and get the easy ones right.
That's right.
That's all.
I feel
Okay? If you luck out and get a hard one right, great. That puts you a step above everybody else. But you don't want to miss the easy ones. That's where it's going to lower your grade. Okay? All right. Let's look at page 929. What I do with, there it is, my writing utensil. All right, so let's find volume, and I want you guys to write out this for every problem. I am going to give you points for writing the formula down for every one. If you don't write it down for one, you don't get the extra points. But there's 10 extra points in 18 homework, Module 18's homework, for you to be writing down the formulas. And what I mean by that is I want you to write it in two parts. I want you to write volume equals area of the base times height. Okay? And then I want you to write, what is the area of the base? Well, that's a circle, so it's pi r squared times height. Now there is 18, what is there, 4? Is there 4 sections? 4 sections. So actually I will tack on I'll do 16 points. That way, 16 extra points for just writing down the formulas. Okay? All right, so my numbers are pi 12 squared times 45. And I'm not doing the last, and well, I guess I'm not, I have a calculator I can copy out of the book, but book's not always right. In fact, this one, the book was wrong. I think it's 20,357.
How do they get the book wrong?
Sometimes the book isn't even the same problem that you guys have. How did they get that wrong? I don't know. Sometimes the problem in your book isn't the same problem that's in his book.
Yeah, that's right.
Whoa.
Yeah, I mean, it's weird.
That's why we should be.
Look at that's it. That's all I got for that one. Okay, so look at though. I want you to look at question 9 in the homework. It says find the volume of that shape.
Is that a micro piece?
So I have volume
Oh, okay, I see it.
equals area of the base times height, right? And I have 2 of them. Plus area of the base times height. I have 2 shapes there. So the first shape I'm going to call the circle. So pi r squared times height. And the second one is that rectangle. Length times width times height. Now I said 15 extra points. That doesn't mean it's a homework assignment worth 15 points. That means I'm taking 15 points and I'm going to tack it. I'm just going to go through and fill in where you need some points. You guys realize that, right? And the way I said it? Extra points. Okay?
Bet.
That's worth a lot more than just a 15 out of a 15 homework assignment.
You right.
What?
The problem is if I'm low each, so will we always just add them together?
Yes.
Or just put them
Unless it's sitting down in something. I think there's some you have to subtract it from. Did you guys hear his question? He said, each, do you always add them together? Well, what happens if I take, if this was filled with water, okay, and I put a ping pong ball down inside of it, what happens to the volume? What happens to the water inside of it?
It goes out.
Volume decreases, doesn't it? Okay, so in that case, I'd be taking the volume of this and subtracting the volume of the golf ball, okay? Okay, so this would be pi, radius is 4. Okay, and the height is 4. That was hard for me to see at first. And then now when you're looking at a prism, a rectangular box, does it matter which side I call the base?
No.
No, it will at points, but on this it doesn't. So what, it's just I have to use all 3 numbers somewhere. Do you guys understand that? Does it matter where? No, because order doesn't matter in multiplication.
Nope.
Okay, so I'm going to do 14 times 6 times 12. Okay? Because it just doesn't matter. Does it make sense why it doesn't matter? And I have shapes I'll get out too. And then you just add those together. Okay? And I really don't want to do any more today. So you guys may have, on review day, you may actually have a little bit of homework to do also though.
We're fine with that.
Yeah, it's okay. We'll get to that.
either that or 18.2 we won't do, we'll just see, but I so I've got, oh, I do have to show you. I have to show you one thing though. That's why I didn't want to go on. That's why I knew. You got, what did you do? I don't want to, I'm afraid to ask him to reach up and get something. I don't know whether to show you. No problem. I can do it. You can ask me, you can ask right
Sure
there.
can hold the world.
Wait, what, Miss Sharp, what is it?
Here you got it.
That was dangerous.
I was gonna ask you, you're all the way over there, I was afraid to ask you. Well, I didn't know what I didn't want you to stretch him. Okay, so. Okay, this is important. Does it matter what my base is in this thing?
No.
Okay, now a base.
I had to take the ACT.
See you? Oh.
Let's go.
You got 36.
Now, it's your homework time. I don't have to tell you about this. It's up to you, but you want to get it right. Because it does matter. What in the world? Now, a base has to have the same shape on the other side. And do you see that? I cannot consider this the base.
Right.
So the other side.
Okay, I can't consider this the base, can I? This is the only one, this triangle is the only one that I can consider the base. Okay?
Okay.
So there's a problem, I think like number 4 or 5, that's a triangle shape. You gotta pay attention. See, on this one, it doesn't matter. I can consider
So
these.
that's when you have to
these.
like, that's when the base and height do matter. Like
Pardon me?
the numbers you put for the base and height. You know how you were saying that it doesn't matter, like
Right.
now.
Because
it
this one doesn't matter.
Okay, now.
Because look, I have this, I could consider the base, right?
Yeah.
I could consider these two the base.
Mhm.
I can consider these two the base, right? It doesn't matter there. So I'm glad y'all are paying attention to me. I'm watching you. Okay, so it does matter which ones.
Understood.
And that is it.
I am ninja diamond razors now.
Your homework
Stop.
Like this.
Just like this one.
is on page 932.
What's the weird stuff?
Oh, I forgot about. I want you doing 1 through 7, 9 through.
One, three, 7.
Oh, that's dumb.
13.
Yeah, that's not something.
I guess that's it.
Do you want me to put these up for you? Or do you need help?
It does not.
Hang on. No, 'cause I
Want this one open?
See, this matters what you consider the base. You can't consider this the base because there isn't another one on the other side. Okay, so this has to be the base, the triangle part.
I don't know. You got a 36.
I feel like I did pretty good.
So as long as there's one on the other side, it can be the base.
Was it hard?
Yes, as long as there's the same thing on the opposite